going on YouTube? Today we are working on a Klein Tools. Looks like something 3. I don't know what that means. This is a USB-A, USB-C charger, little power bank. It's a little rugged, a little rough, and then it's got 13,400 milliamps, and it is a model KTB2, Kilo Tango Bravo 2, and its total wattage is 28 watts. It is, I don't know much about electrician stuff, but it's got the ETL Intertech certification, and it doesn't have an IP rating, so it's not waterproof or water resistant. They probably just didn't want to get through all the trouble for this, but things you'll need are 18 650 batteries, a vise just to kind of hold the batteries in place, like snips to cut the stuff you'll need to spot weld it. You'll need a spot welder to spot weld the batteries. You can't use solder. Pliers. I use spudgers, some prying tools, a T6 torque bit. I used a small little flathead, and I used a ceramic tape and some scissors to kind of isolate the stuff. I did fix another one just to kind of play around with, did a test run with it to make sure everything works fine, as I typically don't get battery packs to repair, so I just want to make sure I did everything right before I videoed it. I did still video the other one to kind of document anything that I might have missed. So without further ado, let's get started. So if you flip this over, you'll have 6 Torx 6 screws, or whatever they're called, T6 screws. So you're going to start by unscrewing them. Fortunately, there's no waterproof seal, and these are the only 6 screws that you'll be unscrewing unless you want to get further into the device. This is good if you're wanting to take it apart and work on the USB-C port, if you just damage it for some reason, or any other case that you can think of. So just these 6 screws. It does have a tight, I'd say, hold on the device. There's not a seal, but it's just tight, which is still good. Like I said, I don't think they wanted to go through the whole process of getting the IP rating certification. So last time I started down here, kind of took the spudger and kind of worked my way in the corner to kind of open it up. You know, I recommend using plastic, but if you need to, use like a small razor blade. Just watch out for your fingers and don't go toward yourself. Also try not to get underneath the rubber too much. I like to just put it in and kind of slide it. You should be able to start working it out. Like I said, this is a tight fit, and that's why I decided to show y'all the one I've not opened up yet, because the other one that I already opened up worked out fine. Kind of just go side to side, see if that does anything. Let's try this other corner, see if that helps. Try this other spudger. It looks like it's still got some life on the actual wedging part. I love my spudgers. I go through them all the time, but I do not like getting rid of them. That seems to not be helping. Let's try the top part. There we go. So now I was able to get into one of those corners, and you can tell the orange is starting to come up. So just kind of like pry it a little bit. Let's try this other corner, see if that helps. Nope. So go from right here, put the spudger back in, see if I can get underneath that. It's kind of got like a little overlay. I don't know if you'll be able to see it well. Let's take one of these prying tools. There we go. All right, now that I'm underneath, that was probably the worst angle to go. Take my spudger and wedge it through, but not too far through, because I don't know what's underneath. That could be damaged. Got my spudger through, and it fell out. I thought I had the pry tool that wasn't all the way through, but now I got it opened up. I'm gonna go around with this and kind of like angle it just a little bit to kind of loosen it up. Again, be careful. Now down here at the bottom, it's just the battery. And as long as you're using a plastic tool, you won't have to worry about puncturing that battery. They're usually covered in steel, so it should be all right. All right, there we go. Now it should be, there we go, fully openable. I don't know if openable is a word, but it is today. So here's the components. Basic little, I don't know what you're going to call this, but the USB ports, USB-C port, just the board layout, and yeah, just the two battery ports. You got this little black cable right here. This is the thermometer battery, and yeah, that's pretty much it. It's a pretty simple build. Just gonna take this and get underneath here, so that way I can pull this first little thermometer out. Do the same thing right here. Now this last one didn't give me this white crud, so just be careful about that. Set those to the side, and then I'm going to use a small flathead to kind of get into there and try to loosen that up. Also looks like some of this gunk. I don't know what this stuff is called, but I've seen it before, and stuff like this, like a little like closed electronics that's not really planned to be maintenance or worked on. It kind of just gets everywhere. And oh, that looks like they just didn't dry or something. But okay, so these are the batteries we're going to be replacing with. So let's just go and do a quick test. These are 3.5 volt batteries. These are also 3,400. And quick math tells me 3 times 4 is 12, and then 4 times 4 is 16. So 16 plus the 12 makes, or 120. I don't know. It was close enough to 3,400, I think. I'll just put the right math right there. Let's see if I'm still in A frame. I am not. Okay, so I'm gonna put that up there. Got my multimeter right there. Got it in DC. Got the positive end right here. Negative end right there. 3.5 volts. 3.5 volts. That's good. That's good. These are brand new from the 650 volt or 650 battery store. I don't know, 1800 battery store. I don't know what they're called. I've hardly ever got to work with these batteries. I know they're in a lot of power tools and a bunch of other stuff. So this is my first time getting to work with these batteries. So 3.5 volt and 3.5 volt. All right. So enough of me yakking about that. Put these new batteries off to the side. Now we have this stuff. I'm going to take my flathead screwdriver bit and the tip. Put it in there, and you want to be very careful doing this. Now I tried desoldering this and it didn't work. It looks like the way they have it made onto the board is it's like integrated. So I'm just going to take it from the back and work my way in toward the board. You want to be very careful and not apply too much pressure, because one, you don't want to rip this little bit, and you also don't want to slide your screwdriver across the board and risk damaging any of the components. You also want to go away from yourself so that way you don't cut yourself. I've nicked myself a notorious amount of times with flathead screwdrivers. And I'm choosing to use a smaller screwdriver just because it's nice and thin and can usually get underneath these little spot welds. And I can usually kind of wiggle it out. I've also tried just pulling this up, but I'm worried that if I pull it up too fast, that I'm going to strip the traces for this. And I don't want to have to retrace this if I don't have to. So just like this one's doing, I got behind it and it kind of wiggled it a little bit while applying some light pressure, and it kind of lets you get between the spot welds, or the tacking, or whatever you want to call it. I'm just calling it spot welding because that's what this is a little spot welder, and it kind of breaks the little spot welding. Now whether or not that's the right way or the wrong way, I have no idea. There's not like a certification that I'm aware of that you can get for this kind of work. It's kind of just do it on your own and hope you don't break it further than it came. So we got this little cable right here. I don't know what it goes to, so you want to be careful of that. It looks like it's the light cable. Again, don't want to break more than I have to, or don't want to break anything that I don't plan on or don't want to plan on having to replace. It came here for batteries, so it should be only batteries. Alright, now that came up, so this should come off, no problem. There we go. And I do want to salvage these two pieces right here just because they're already angled and it's going to be hard to kind of, it's just extra work to have to make more spot weld angles like that. So I'm going to flatten this out. If you want to go ahead and just not reuse this and just do your thing like that, you do your thing. This is just how I'm doing it, just because this spot welder kind of scares me. Now, if you've never used a spot welder before, definitely take some time and practice it on your own, just to kind of get a good feel for it. Now, this I might be able to just peel it off. Don't want to go too crazy with it, so I'm just going to kind of, yeah, there we go. Now, if you're able to, you can probably resalvage this if you don't have, if your spot welder didn't come with any of this. I don't know what this stuff is called. I like knowing the names of things, especially if I'm using it. See if I can flatten that out. Yep, there we go. Be careful, this stuff is kind of flat, so it is sharp enough to cut. I don't like wearing gloves because it gets in my way, but if you need to wear gloves because you're scared to get cut and see blood, definitely wear gloves. Or just have someone like me work on it. Alright, there we go. That came off. And now this side, it's got this little coating stuff on here. I don't know what this is as well. I've seen it on batteries before. I think it's just to keep the terminals isolated, but right here and right on the other side, it's not really isolated. So you can always put ceramic tape just to kind of cover it up, and that's what I'm going to do just to be safe. Ceramic tape is non-conductive, so it'll be fine for stuff like this. All right, so now we got that. I'm going to take this and flatten it out. Again, you don't have to do this if you don't want to. This is just if you want to kind of repurpose some stuff. I definitely recommend to have the material you're going to use to be as flat as possible, because any kind of like angle is going to make harder to contact onto your thing. So I'm going to take this vise. Now this, if you look at this, they're all in a parallel circuit, so all the negatives are in one spot, all the positives are in one spot. You can tell the difference by the fact that this one's flat and this one has a little dimple right there. So this is the positive end, that's the negative end. It doesn't say it on the battery. Well, it actually does. So you got the little negative right there and the positive right there. So if you need some help, there's that. I want to use this vise to line these up, so that way I don't have to worry about it getting out of line. Let's see, I'm going to use something to kind of hold it flat up. Yeah, I guess you're just going to have to, depending on your vise, you'll have to probably do this, but try to hold this as level as possible. All right, there we go. I'm going to tighten it, make sure it's nice and flat. And I'm going to take this piece and lay it on here. I don't like touching the metal when there's electricity ran to it, like from the spot welder, because it looks like it creates a large voltage and creates a little spark. So turning on my spot welder, trying to hold the two pieces. I wonder if I can hold them right there, but I'm too scared to. So let's see. All right, spot welder's on. Now I'm going to take it, I'm going to press down with my dominant hand onto the piece. I'm going to move it a little closer, trying not to get these two pieces to touch because you don't want to spot weld the two pins. And oh, I slipped. I'm going to press down hard. All right. Press down hard with this one. All right. Again, if you haven't spot welded before, I definitely recommend getting some practice in before you take on a job like this, because the sparks are scary if you don't know what you're doing, like me, before I did this. All right, there we go, pressing down. Holding it down for about 2 clicks. Make sure that these, well, it's not gonna work. Make sure that these are nice and spot welded. So, yep, nice and good. Flip it over and put them right there. We'll try to bind them together so that way when we spot weld them, they'll be nice and lined up. All right, now I'll take this. Now I'm not going to worry about the metal and all this because there's no direct connection. And there we go. So now we'll take this again, hold it down. Oh. Right. Pressing firmly. Oh, that slid. There we go. Pressing firmly. Pressing firmly. You can probably see it kind of like beating too. It's because it's putting all this electricity through. I don't even know how many volts it's putting through. There we go. Now that since I already got this side here, I'm going to go ahead and, now this is the negative side, so it'll be one like that. So do the other one. Was it like that? I feel like it was. Yeah, it looks like it matched. You can kind of look at this too to kind of see where this will line up. It's going down, so this looks like it's the other end. So worst case scenario, you just gotta cut it off and redo it. Do as close as we can right there. Now you gotta be careful, you're gonna slide a lot, so we'll place this right there, nice and firm. And there we go. Flip it over. Take this piece. Now that I'm looking at it, well, there's that. It kind of makes you question if it even was there. It probably would have made sense to mark which one was which, goes where. Holding it down nice and tight. Taking this, get a better angle, and see, there's that spark I was telling y'all about. You gotta be careful with that. I knew I'd get one at least, and nice and spotted on there. You want to make sure that none of them are loose. All right, now we're good to go. This is safe to touch as it's the only 3 volts DC, and not a crazy amount of amps that's going to kill you. Holding this. Now let's do the ceramic tape just for safety. Again, this is optional, but if you like just having some kind of feeling of protection, you can do this. Now I know I said something about not knowing much about electricity. I know a general idea of electricity, and I feel like if you're going to be in any kind of like repair field, you need to have some kind of grasp of how electronics works and what's good and what's bad, so that way you're not so scared. But also whenever you, what's the word I'm thinking of? Whenever you work on electronics, it's almost more scary, because then you know what's gonna hurt you. So fit that in place. And yep, I think I got that one on the wrong side. Fitting that in place. I heard a click and I thought my life was over. That's nice in there. So take this, place it firmly, and there we go. pushed in. Make sure that's nice. All right. Now, line it back up a little better. There we go. I'm going to turn this off because it's terrifying. All right, and then I'm going to take these thermometers, and I'll line them back up. Be careful not to get them in between that screw hole because you don't want them getting damaged. And then take this ceramic tape. Recommend using ceramic tape and not electrical tape just because this is more aesthetically pleasing in the thing, but I'm sure there's another reason why. I've always seen ceramic tape in electronics and not electrical tape. I'm assuming there's a reason why, and I'm sure any electrician or somebody else that knows, drop in the comments, please, for me. I'll lift this up, do that, and that's good to go. Let's do a test to make sure it's good to go. I'm going to press this button, and lights come on, that's good, and lights should come on. There we go. And let's make sure it's going to charge. So I got I use a laptop charger for this. It does all kinds of range of voltages. I like having a little voltage tester for USB-C. Any kind of work I'm doing with USB-C. Looks like it opens up right here. And do that. And plug it in. And we're good to go. All right, let's put this back together. Make sure nothing else is there. And put this back on. Now, I don't know if y'all remember me talking about there's no seal, but it does have this like, kind of like little lip. It's got like grooves right there, so this will fit right into the grooves. It's going to have like a small snap. There we go. Then I'm going to have to clean this off. I'm probably going to use like Windex to kind of clean that off. I would use rubbing alcohol, but rubbing alcohol leaves like a residue. Not really a residue, but just a weird whitish stuff, and I think that's because it dries out the plastic. Put these screws back in, and we are good to go. If y'all have any questions or anything like that, I can probably answer them to the best of my ability. Everything that I know about these things are for sure in this video. I don't know much more of it. I don't know the history of this item. I don't know any other like deep, like common issues. So yeah, hopefully this helps y'all out and keep these battery packs alive and keep less stuff in the landfill. I'll drop the link to the batteries that I used for this repair. And yeah, thank y'all for watching, and I'll see y'all in the next one. Peace.